Hi everyone, in this part of the FPS tutorial series we are going to add some improvements to the game, which by the way is not required, but having them is going to greatly enhance the overall gameplay experience. So in this video we are going to add the following improvements in our game. First of all, we will add weapon sway, which is going to make our weapon rotate around as we look around with our mouse. Then we are going to fix the clipping of weapons into the walls. Implement ADS, that is aiming down sights, which you must have seen in a lot of games. And finally add head bobbing when we move. And also add a little feedback when we sprint. Also, I would like to point out that this video about weapon swaying from YouTuber Garbage really helped me a lot. So my approach is going to be similar to the one in this video, but the implementation is going to be a little different. So let's start by adding weapon sway. In the ARM script, let's implement the required logic for that. Here, sway pivot is going to be an empty spatial node which we will create at runtime. Then inside the ready function, call setAsTopLevel method of the spatial class. So what it means is that after calling this method, the weapon is not going to move based off its parent position and rotation. After this, we call a function we are about to create by using the callDeferred method. Now let's create the function which we are calling in ready. First, we create a new instance of spatial node and store it in a sway pivot variable. Then we have to add it to a scene. In our case, we add it as a child of the weapons node, and then set its position to this weapon's position. And optionally, I am setting its name to this weapon's name with a sway as a suffix. Then create another function which is going to be called each frame. Here we set our weapon's position to sway pivot's position. And why we are doing this is because our weapon is now not following its parent's transform. But since we created the spatial node earlier, we can use its transform as a reference for our weapon. So for position, we are directly copying it from sway pivot. But for rotation, we will interpolate the weapon's rotation to the sway pivot's rotation, and that would give us the sway effect we want. So first we get rotation of both weapon and sway pivot in quaternion and store it in a variable. Then we will use the slurp function for interpolating from weapon's rotation to spatial node's rotation. Then finally set the rotation returned to our weapon. Now back to the play script. In process weapons function, we will call the sway function of the current weapon we have equipped with only one condition, that our current weapon should not be unarmed. Additionally, I am going to put the process weapons function inside the process function, though this is completely optional to do. Now let's run the game and see the result. As you can see, the weapon is trying to rotate towards the sway pivot we created, and this gives a pretty good effect of swaying. We can try it with other weapons as well. Now that weapon swaying is working, let us look at a problem we have right now with our game. As you can see, if I get close to a wall, the weapon goes under it. So there are some ways through which we can fix this. We can try adding a collider to the weapon, and that would simply solve our problem. but at the same time it can cause unnecessary collision while moving on top of certain objects. So instead we can use camera stacking to solve this issue. In player scene, let's add a new viewport to display our weapons. For that we need to first add a viewport container. Now add a camera inside the viewport. I'm going to name it Weapon Camera. We also need to make sure that it is aligned well with our main camera so that we can see it inside the editor. Now if we run our game, we see our new camera stacked on top of our main camera. But as we can see, our new camera doesn't cover up the whole screen. For that we need to check the stretch property of viewport container to true. Then on viewport node, set transparent to true. And that seems to fit well. Now we have to make the weapon camera follow our main camera. For that, let's create a simple script. So first we create variables that would get reference to our main camera node. Then in process function we simply set weapon camera's transform to the main camera's transform. And this will copy the position, rotation and scale of our main camera to the weapon camera. Also don't forget to set main camera's node path from the inspector. So that's working fine. Now we need to do just one last thing to make the weapons render on our new camera. Select the weapon camera node, then under the cull mask property, disable all layers except for layer 2. Similarly, select the main camera and here disable layer 2 only. So what it does is that our main camera is going to render all objects except for objects that are on layer 2. Similarly, our new camera, that is the weapon camera, is going to render objects that are on layer 2 since all other layers are unchecked. So to make it work, we need to set the meshes of all of our weapons to layer 2. And also make sure to set muzzle flash particle effect to layer 2 as well. Here we go, our weapon is no longer going through the walls. Now before proceeding ahead, I will like to point out that there is a problem with viewports that they do not render certain environment effects. So to demonstrate the issue, I am adding a world environment node and doing some basic setup. Now I am going to change some properties in the glow section. Now this affects all objects rendered by our main camera, except for the objects, that is the weapons rendered by our second camera. So I'm not sure if there is something I'm missing out or if it is some bug. But anyways, I'm going to undo the changes I did on glow properties, though I'm leaving world involvement node in the scene as it is. Now let's set up ADS, that is aiming down sights, for our weapons. So let's start by defining variables for ADS. ADS pose is the position of the weapon while we aim down sights. ADS speed will be responsible for controlling the transition speed between ADS and normal mode, while isADS tells us about whether we are aiming down sights with our weapon or not. Similarly, we will define the same set of variables in the unarmed script, with the only difference that we won't be having ADS pose over here. Now before we write any further logic, let's set up the value of ADS pose for all of our weapons. So select the weapon camera and switch to its preview mode. Now start with any weapon and move it around until you are satisfied with its position for ADS. In my case, I usually set the value of x-axis to 0 and do the changes only in z-axis. After having chosen your desired position, copy its value to the ADS pose variable we created. Now back to player scene, we can set position of our weapon to its original position by copying values from equip pose variable. Now I'm going to do the same thing for all other weapons. Since this is quite a tedious process, I'm going to fast forward this sequence. Now that we have done setting values, we won't be doing any changes to weapons anytime soon, so I'm going to remove old weapons from the scene. And as I told in the previous video, it won't make any difference to how our game works, so we will still able to equip all of our weapons anytime we want. Now before we resume writing code, I would like to quickly mention one more thing about cameras. Here we have this FOV property which stands for field of view. So a higher value means we can see more around us, whereas a lower value means the opposite. So when we would aim down sights with our weapon, we are going to lower the FOV of our main camera during that time. Now back to the ARM script, let's create the logic for ADS. So the function aim down sights is going to run per frame similar to SOE function. So first we set isADS to the value parameter, which is either going to be true or false. Then if it is true, meaning we are aiming down sights, in that case we interpolate SOE pivot to ADS pose by a speed of ADS speed, and this is going to move SOE pivot to the ADS position, which in turn will move our weapon. Similarly, we are going to interpolate main camera's FOV to a lower value than it is right now. Now here I am hardcoding these values for FOV, but you can create a variable for having a better control over these different parameters. In the same way, if we are not aiming down sights, we do the same exact thing but in the opposite way. Now I will copy this code and paste it in the unarmed script. Also remove the sway pivot statement as we don't require weapon swaying while we are unarmed. Then create an action for ADS. Now in the player script, let's head towards process weapons function. So when we are holding down the ADS key, in my case it's the right mouse button, then we call aim down sights method of current weapon with true as the argument. Else we do the same thing again, but this time having false as the argument. So let's run the game and see the result. And it's working just as we want. Though while we are aiming down sights, our weapon is still swaying. Now to make it look more realistic, it would be a better idea to hold the weapon still while we are aiming. So we will do a little bit of change here. In sway function we created, separate out the declaration of new quad variable in its own line. Then if is ADS variable equals to false, we do the interpolation as we were doing before. Otherwise, if it is true, we directly assign new rotation to new quad variable. Also, to make our code a little bit more optimized, we are going to check whether we are aiming down sights or not, and if we are not, then we return out of the function. Then copy these two lines and paste it in the unarmed script. And this seems to look much better now. Now let's set up head bobbing for the player. So first I'm going to add an animation player node to the scene. Then we are going to create an idle animation. So in order to animate head bobbing, we will have to move our main camera. But a better way would be to create another parent node for the camera and move it instead, as this way we will be leaving the main camera untouched. So I'm going to add a spatial node to the scene and name it head bob. Then make it a parent of the camera node. Now since we moved camera node inside this new spatial node, we need to do some changes in our code. Starting with weapon manager script, we need to update references for only the raycast here. So I will declare a node path for the raycast, and this will allow us to set raycast from the inspector. So the advantage here is that if we rearrange our hierarchy, even then Godot will keep the correct path to the node we selected. After this, we just have to set the node from inspector. Then in the player script, we will create node paths for camera and weapon manager. Also, don't forget to set the nodes from inspector. Now, just to be sure, let's run the game and see if everything is working fine or not. That's working good. Now let's resume by animating the head bob animation. For idle animation, we are going to keyframe the default position of head bob, which should be 0 in all 3 axes. Then we are going to create the head bob animation, which is going to add a pretty good immersion in our game. Here, move the head bob node in any direction you want. I'm changing its position in y-axis. Then in player script, we are going to create a new function which will be responsible for head bobbing and the sprint effect which we are about to create. So if we want, we can do a basic if-else with dir vector, which holds the information for direction we have to move. So if it is 0, we play the idle animation. Otherwise we play the head bob animation. Also, I am setting blend property to 0.1 so that the transition is not abrupt. Then finally, in process movement function, we call the function we just created at the very end. Now let's run the game and see how it works. So it's working quite good. But if we keep moving towards a wall, then we are still head bobbing. And that's because even though our kinematic body's velocity should be somewhere close to 0, but the direction vector has some non-zero value with a magnitude of 1 since I'm still holding the W key on my keyboard. So to fix this, we have to check for velocity's magnitude rather than direction vector. Here I'm choosing 3.0 because even when we are pushing towards a wall, we do slide a bit. So velocity's magnitude should be something close to 0. In addition to that, we also check whether we are on ground or not, as we won't be moving our head while in the air. So I'm going to do a little change here. I'm instead calling the head bob animation and playing it on a speed of 0.2 of its original. This way we are simulating the same idle animation but with a slower head movement. Similarly, we compare velocity's magnitude with speed and play the animation on normal speed as before. Otherwise, if all conditions fail, we assume we are sprinting, so we play the animation at higher speed. We can see that while we are idle, our head moves at a lower speed, and when we begin to walk, the speed of head bobbing increases, whereas while we are running, the speed further increases. So that's working fine. Now let's work on adding a sprint effect to our game. So first we are going to add a reference to the weapon camera node. Then in process movement effects function, we are going to check whether we are holding the sprint action key or not. If we are, we interpolate weapon camera's FOV to a more higher value than its default 70. It's the same way we did with ADS, but here instead we make the weapon camera view much larger. Otherwise, if we are not holding the sprint key, we interpolate back to FOV's default value of 70. And it works pretty good. Though if we aim down sights and sprint at the same time, we see that sprint effect is still working on. Now it might look a bit unrealistic, as when we are aiming down sights, we don't want player to sprint, so we have to do just one last thing. In process movement function, we set sprint speed only if we are not holding the ADS key, that is the right mouse button. And in our process movement effects function, we are going to add another parameter, speed. Here speed is nothing but the speed which we are setting in process movement function, which we are going to pass over here. With this speed parameter, we are going to modify the sprint effect condition to a much better one. And that's it, let's run the game and see the final result. Here we go, it's working just as we want. And that's pretty much it. We have successfully added some of the essential things needed to make our game feel much more immersive. So in the next part, we are going to implement wall running in our game. So I hope this video helped you, and if you have any questions or feedback, do tell me in the comment section down below. So then I will see you in the next part.